So this video is on sort of the addition algorithm, or I've often called it column addition, the column algorithm. And this is basically how, in general, we add a pair of numbers in a very compact way. So let me just start off. Let me do 235 plus 643, right? So I've got something like that. Okay, the first thing about this is, like, we got to remember a little bit about place value. So what we mean by that is what? 200 plus 30 plus 5. That's what that first number means. And then I have 600 plus 40 plus 3. Okay, and then we do something. I'm going to ask you in a second what it is I'm doing, what property I'm using to get that. Okay. And, sorry, just a sec. Oh. Yeah. Okay. Okay, sorry for that. So what did we just do there? Right? Well, this was the any order property, or any order addition. It's a combination of the associative and the commutative property. Right? And then these are all pretty straightforward to do, 870 and 8, which again we write as 878. Okay, so that's the first thing to just remember. This is basically just place value stuff that we need to know. So we've got that. All right. So now what we're going to do is we're going to sort of think about this in the column format. So again, I could write this as 3 separate pieces. I could write this as 200 plus 600. I could write it as 30 plus 40 and 5 plus 3. There's nothing really different than this, except that I'm writing them on top of each other, right? And I get exactly the same result. Right? And we're going to compact this all to write it as 235 plus 643 and 878. Okay. So now, before we do that, I'm going to talk a little bit about sort of the chip model or the coin model, quite a bit about this, because I think this is the key part of this. Just as you're going through this, really, some of the really important skills before you get to this for students, right, is first of all understanding place value, right? So if I write 235, what does that mean, right? What does 643 mean, right? And they should be able to kind of understand that. You also have to have your sort of addition facts pretty well built in, right? So the addition, I usually say addition, subtraction within 20. It's all the facts addition with the add-ins up to 10 type of thing. Okay, now let's look at a chip model for this. So I'm going to do the same problem. I'm going to say the chip or the coin model. And here's all we're going to do. So I've got a nice little box here. For hundreds, tens, and ones. And let's write down here that we're still doing 235 plus 643. Okay. So what am I going to do is I'm going to put 200 35. Okay. And 6, 43. Now, I'm not a huge fan, there's a number of ways of doing it. I'm not a huge fan of writing the solution down. You can, I don't think you need to, because of the following. What is the answer? Well, it's sitting right here, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And by I don't write the answer down, I don't write the chips down on another row. So this doesn't, I don't think these chip models correspond one-to-one with the column algorithm directly. I'll talk about how, right? Okay. So in other words, here's the way to often think about this. Right? So if I think about this as coins, again, I got pennies and dimes and dollar coins. And I just have the, $2, 3 dimes, 5 pennies, $6, 4 dimes, 3 pennies, and you lay them on the table. And they're down. And I just want to know how much money do I have? Well, I have $8, 7 dimes, and 8 pennies. Right, so I don't need to write them again because they're all there already. So now some places will do that. If you look at some of these models, either online or other books, this is kind of my preferred way of doing this. Okay, so that's pretty straightforward. Now the reason this was straightforward is once we just laid everything down, the total in each column stayed under 10. Right, and this is where things can change. So let's do a different one. Let's do 375 plus 241. So 375, 1, 2, 241, 375. Okay. And the answer is not that. So let's erase that. All right. So I look at this, I go 1, 2, 3, 4, 5, 6. Perfectly fine, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so here's what. I can have 11 dimes, right? I put this on the table. I have this many pennies. I have 11 dimes. And I have $5. Okay. Now, the only requirement with this is what we want to do is if I have too many in one place value, like once I've reached 10, I want to do a cash out. Right? And so that's the difference between actually having coins, which you can use whatever, and when I do this addition, I really want to do that. So here's what's going to happen. There are 10 dimes, and I'm going to do one like that. And you can just do a nice little cross out. To me, I think this clearly shows that what have we done? I've cashed this out and I've made another dollar coin, right? 100-cent piece if you want to think of it that way. Okay, so now what do I have? 1 left and 6. So 616. Okay, now let's look at the column algorithm. So again, column, and just like we did here, not completely required, but you can imagine that it's useful this way, right? I start at the ones and I go right to left. And the only requirement is if I have too many, I need to do this. So we usually call this carrying. In addition, I like the term rebundling from our textbook. So 6 looks good, right? 7 plus 4 is the 11, right? That's the one that's left, and that's the one I made, right? So there's 1 to there, that one is there, and then 6, so 6, 16. Okay. So I might be belaboring this a little bit, but the thing about it is, like, if you understand this coin chip model, like, just make sure this is like rock solid. Okay. Once this is like this, this is really just a compact way of doing this, right? Really just a compact way of doing this. And you know, it's much nicer to write the numbers down and add them really quickly like that, rather than write down all the coins and do all of this stuff. But this is sort of basically why this is working. So we've got that. Okay, let's see if I... Yeah, I'm going to go ahead and do. There's one other thing I wanted to cover with this, and that is called the lattice method for this. Do a couple of examples here. Maybe we'll, oh, I've totally forgotten what I just wrote down, so we won't worry too much about this. Let's say I'm doing 2. Actually, I'll do some with a couple of rebundlings. 8. Okay, so here's a method that's really quite nice that I'm going to just write. I sometimes need a little more room than normal, so I'm going to write that out like that as a plus. Okay. Now here, what I'm going to do is I'm going to do, let's see, so I'm going to write the answer here, and I'm going to put the 10s and 1s in the upper and lower part of each box. So 1, 4, 1, 1, and 0, 5. Okay, and then all we do is sort of extend these over, and we just write the result down, adding along diagonals. So 4, this stays like that. 1 and 1 is 2. 1 and 5 is 6. Okay, and I could write the 0. So the answer is 624. 624. Okay. Basically, one of the things with this, that one and that one, are, if you did it the regular column way that we just did, are the carries or the rebundlings over there. Okay. This is a great little method for students that are having trouble with the rebundling. This is pretty straightforward, I think, to do, as long as you learn how to do these diagonals. And then you can kind of wean them to the other method, which is a little quicker again. Okay, now, one of the cool things about this is, and I don't have to do 3-digit numbers, but I can add 374, 826, 249. So, actually, let's make this 377. So I'm going to do 3 numbers now, and if there's no, you can keep going as well. So so here's what we've got. So 13 and 9 is 22. 7 and 2 is 9, and 4 is 13. And let's see, I got, oh, those 2 is 10, and 3 is 13 as well. Okay, and then add diagonal 2, 5, 4, 1. So the answer would be, again, 1,452. It's that. That's quite a nice little method. This is a little bit more challenging. It works the same way. Those two, well, 1, 2, 3 are all the carries over, right, or the rebundlings, which again, when you have multiple numbers, they can be bigger than 1, so you could have 2, or you'd have to have 4 numbers to do at least 3, but you could do that as well. Okay, so that wraps up the